All right. So M1V1 equals M2V2. This is going to be the formula that you're going to need to know to solve your dilution problems. And so what does each of these variables stand for? Well, the M is referring to your molarity, and V is referring to your volume. And this volume can be in either units of milliliters or liters, as long as your V1 and V2 are both in the same units. So if V1 is in units of liters, V2 also needs to be in units of liters. If V1 is units of milliliters, then V2 must also be in units of milliliters. And so, depending on the problem, this M1V1 M2V2, right? The M1V1 could be your initial molarity and initial volume, and M2V2 are your final molarity and final volume. So really, depending on the exact context, what is what can vary. But just remember that each of these are differing molarities and volumes, really. And so basically, what we're saying here with this formula, right? Well, we know that our molarity, this M, is really just shorthand for moles per liter, right? And so this is a unit of concentration, molarity. We're looking at concentration here. And so with our problems of dilution, right? Whenever you're diluting anything, you're really only adding solvent, like water. You don't add or remove the actual solute particles, the stuff that is being dissolved, right? Think of salt water, for example. If you add or if you have a cup of salty water and pour in another cup of pure water, the total salt is going to stay the same, but now it's just spread out in more liquid, and so the concentration decreases. We can just look at our moles per liter itself, right? If we have this fraction, moles per liter, and we increase this volume by adding more water, we increase the number of liters of water, well, we now have a fraction with a numerator and a very large denominator, or a comparatively larger denominator than we had before. And so the value of this fraction is going to go down, or in other words, our concentration is going to decrease. On the other hand, again, looking at the same exact, expression of moles per liter, if, for example, we have a solution and we remove some of that water, now that we're looking again at our salt solution, again, like in the previous example, well, now that same amount of salt is going to be distributed over a smaller volume, so it's going to be more concentrated, decreasing the value of our denominator. Decreasing the value of the denominator of a fraction is going to result in an increase in the value of that fraction, right? And that's exactly what we're looking at here. So by decreasing that volume, we're going to increase our concentration. And so again, just keep in mind that when we're diluting anything, we're diluting a solution, right? The number of moles of solute is staying the same, and that is the very principle upon which this concept of the concept of this formula M1V1 equals M2V2 is based upon. So when we have, basically, let's keep in mind that our moles before is going to equal our moles after. And we're saying after and before, we're referring to changing the volume. So by changing the volume of that solution while adding water or removing water, right? In the case of dilution, we're adding, let's say, water. The moles of solute before and moles of solute after are going to be staying the same. And so really, by looking at this formula, just rewriting it in another way, we can see that moles, or M1, right? It can be moles 1 per liter. Remember, we can write moles per liter. And our volume is going to also be in liters, right? Is going to equal to our moles 2 per liter times volume again in liters. And so this is going to cancel out the units of liters in this way, and we can see exactly what we have here, that our moles in the beginning and after are going to be the same. And so it's based on this idea that we're able to use this formula, manipulating it to find whether different molarities or volumes of solutions before or after diluting. And so again, it's because that our moles before are equal to each other that we can write this formula. So just as we said before, just keep in mind that numerator is the same, but increasing the denominator, or in other words, increasing the volume, the fraction of molarity, that molarity fraction is going to get smaller. And if you decrease the volume by, let's say, evaporating the water, the fraction is going to get bigger, and we're going to have a higher concentration. There's no reaction happening here, so no new moles are forming or being used up. You're just spreading out or concentrating the same amount of solute. So again, just as a summary, dilution is all about spreading the same amount of solute over a different volume. We're not creating, we're not destroying any particles, we're just changing how packed they are in solution. All right, now that we've, cleared that up, let's work through some example problems. All right, how many milliliters of a 2 molar NaCl solution are needed to make 250 milliliters of 0.5 molar NaCl? Well, let's first just write out our formula, right? We see this is a dilution problem, so we can write our M1V1 equals M2V2. And now what we have to do is just identify what each of these is going to be in the context of our specific problem. Well, we can see that we're trying to find how many milliliters of a 2 molar NaCl solution. Well, we can see that we're given the molarity already. So that will be our M1, are needed to make 250 milliliters of 0.5 molar. So we can see that we have to add some amount of this solution in order, we have to add some volume to make a given volume and a given, given a specific volume of specific molarity. And so we're going from this to this. So we know this is what we're trying to go to, the end product, the after. So we can identify these both to be our M2V2 specifically. So if we kind of just put out parentheses, making space for each of these variables that will be in the problem, well, we know our M2, what molarity we're trying to get to here is 0.5. And we're trying to get to 250 milliliters of that. And we know that we're starting off with a 2 molar NaCl solution. So that's our M1. And we don't know the initial volume. So we're trying to solve for V1. So really what we have to do now is we're given this expression, right? Now we just need to manipulate this algebraically to isolate for V1, which is what we're trying to solve for. Well, just manipulating this expression, how can we do that? M1V1 equals M2V2, and we want to isolate V1. Well, we'll just divide both sides by M1. And this isolates our V1. So we see that V1 equals M2V2 over M1. Well, now let's do that exact same thing with our volumes or our values in the problem. So dividing both sides by our M1 gives us V1 is going to be equal to 0.5 times 250 divided by 2, giving us an answer of 62.5. And so what is going to be the units here? Well, remember that we said our V2 and V1 must be in the same units. Well, I mean, it's already given to us in the problem that we need to find it in milliliters. We're dealing with milliliter here already, which means that our units here are going to be milliliters. And so this is the answer to this problem. So we're going to need 62.5 milliliters of the 2 molar NaCl solution in order to get our desired volume in solution that we were talking about. All right, let's look at this one now. So you have 100 milliliters of 1.5 molar HCl. What will be the concentration if you dilute it to 600 milliliters? All right, so same thing with the last problem. Let's start out by writing our formula. M1V1 equals M2V2. and just identifying what it is that was given in context and what it is that we're trying to solve for. Well, we're told to start off with we have a 100 milliliter and 1.5 molar HCl solution. So we have this already. We know that then will have to be our M1 and our V1 respectively. Well, not respectively, but yeah. So our M1, 1.5, our V1, 100. Okay, so now what about our M2 and V2? Well, we're asking for what will the concentration be if you dilute it to 600 milliliters. So we're diluting it to 600 milliliters, meaning our final volume is going to be 600 milliliters. We're going from 100 to 600. So we're given what that final volume is, which is our V2. So we know this is going to be 600. And we are trying to find the concentration, which means we're trying to find this value of M2. So we're trying to find M2. So what do? We isolate this, we isolate M2 in this expression. Writing out our formula again, how would we solve for M2 if this is what we're given? Well, we would just divide both sides by V2. Dividing both sides by V2, we cancel V2 on this side, and it gives us our M2 is equal to M1 V1 over V2. Well, doing that exact same thing here, we know that we can solve for our M2 by taking 1.5 times 100 divided by our 600. And this gives us a value and our answer of 0.250 molar. So this is going to be the concentration if we dilute a 100 milliliter 1.5 molar 100 ml HCl solution to 600 milliliters. All right, now let's look at this one. A student has 50 milliliters of 12 molar HCl and wants to make 1 liter of 1 molar solution. How much water should they add? All right, once again, we can start by writing out our M1V1 equals M2V2. And let's identify what it is that we have and what it is that we are solving for. Well, we have, or the student has, 50 milliliters of a 12 molar solution. So this is what we're starting with. So these are going to be our M1 and our V1. So M1 is 12 and our V1 is 50. And well, now we want a 1 molar solution, right? So that's our M2. And we want to find out the volume here. So that is our V2. Okay, as before, how can we manipulate this to isolate V2? Well, if we want to get V2 by itself, we divide both sides by M2. Canceling M2 on that side gives us that our V2, that gives us that our V2 is going to be M1V1 over M2. Right? That makes sense. So, what do? Well, we take 12 times 50 divided by 1. And this is going to give us our V2, our final volume, which is going to be equal to 600 milliliters. And well, is this our final answer here? No, it isn't. Because look at the problem. What are they asking for? They are asking for how much water we should add. So that's a classic trap. Don't stop at the final volume here. This answer of 600 milliliters is not what we're looking for. That's why it's very important that you're not blindly plugging and chugging into a formula, just assigning values to the variables. Understand what each of the variables and each of the values mean in the context of the problem. So, In this problem, this 600 milliliters is the final volume of solution. We have to add some amount of water in order to go from our initial volume to our final volume. That is going to be what we have to do to dilute from 12 molar to 1 molar solution. Well, how do we go from our initial 50 milliliters to 600 milliliters? By adding some amount of water, and which is what we're trying to find. How much water is that? Well, we can find that by simply taking our V2 and subtracting from it our V1, or taking the 600 milliliters that we're ending up with and subtracting from it what we started off with, which is going to tell us how much water we had to add. And in this case, that is going to be 550 milliliters of water, added. 550 milliliters of water added. And this here is actually what our final answer is going to be. So I hope that made sense. Again, just keep in mind those common mistakes of 1, forgetting that you have to be consistent with your units. That is, both V1 and V2 have to both be in either milliliters or both be in either liters. If you're given in milliliters and we're trying to follow for liters or vice versa, remember to convert between units and stay consistent when using M1V1 equals M2V2, or you will get the wrong answer. And the other thing, again, to keep in mind is remember to always keep in mind what the question is really asking. Do not forget what the question is really asking. Like in this final problem or this last problem, we're trying to actually find not the volume of the solution at the end, but how much water must be added in order to get there. So keeping that in mind, again, I hope you guys found some value out of this video. If you did, please show your support by liking and subscribing, and leave in the comments what you would like to see next or any other questions that you may have. And I'll see you in the next one.